Okay, let's look at the effects of ionization. So let's examine this word, ionization. What does that mean? That basically means when your drug has a charge. So if you see like a plus or a minus next to the drug, that means that drug is ionized. And I'll talk about why that is important. What I want you guys to understand is sometimes the drugs we take, they can be acidic or they can be basic. And if a drug is acidic or if a drug is basic, it enters our body, it does different things in our body. So let's kind of put it all together. Let's say I take a drug, okay? And when that drug enters my body, what happens is the drug splits into two. You can get ionized drug where there is a charge. So when you see a plus or if you see a minus, it means it's ionized. It means there's a charge to the drug, so the drug splits into two, right? So it gets ionized, and then there's some drugs from that one drug that is unionized or non-ionized. Now, what's important to know is that when the drug is ionized, what tends to happen is it will not enter our cell. And if you look at this over here, let's imagine this to be the cell membrane. Actually, maybe what I can do is I can show you this picture because this is a better picture. So when you're looking at this drug that is not ionized, there's no charge to it, you don't see a plus, you don't see a minus beside it, this drug will easily pass through the cell membrane, the lipid membrane. So it'll go into the cell and then go into the bloodstream, and the drug will do what it has to do, which is good, right? So if you want a drug to work, it has to pass through the membrane. But what happens if you have a charged drug? If your drug is ionized, then what happens is it won't go through. It'll just bounce back. It'll just stay in this area. It will not go through. And the way to remember this is if you have a plus on top of it, it's very bulky. Think of it as bulky. And when it's so bulky, it's too bulky to pass through. It's not going to be able to pass through the cell membrane. So when you have a drug that is charged, that is ionized, it is too bulky. It is not going to pass through the cell membrane. It's just going to bounce back up. It's what we call water soluble, and that means it's just going to stay in the water. It's not going to go through the fat. It's not going to go through the lipid membrane. However, when you have a drug that is non-ionized, that is unionized, there's no charge, it's lipid soluble. That means it will go through the lipid membrane. The cell membranes are made up of lipid membranes, which is like fat, and it will go through, and that's because it's not bulky. So when you have something that's bulky, too bulky, it's going to bounce back. It's not going to pass through the membrane. When you have something that is not bulky, that is not ionized, that's great because it's going to pass through the lipid membrane, our cell membrane, and then do what it has to do. It's going to start working. Let's look at, you know how I said some drugs are acidic and some drugs are basic? Let's look at what that means. So there's something called a pH scale. So let me bring up the pH scale, which is right here. This is our pH scale. And you can see that if you have a pH of 7, so if in our body, our stomach is actually very acidic. So the pH of our stomach is a 2 actually. And our intestines, for example, is a little bit more on the basic side. So the intestines might be around 6 or 7. So our body has different pHs. Now, if I say that something is acidic, what does that mean? Well, that means that there's lots of hydrogen ions. Or some people call this protons. So there's lots of protons in the acidic environment, in that acidic part of your body. So in the stomach, for example. And if I say something's a little bit more basic, what that means is that there is no hydrogen. They actually remove the hydrogen ion. So there's not much hydrogen ions. So your intestines, for example, is a little bit more on the basic side. And because it's more on the other end of the pH scale, although it's not all the way here, but it is somewhere around here. It's going towards the basic side. That side means that there is no hydrogen ions. Okay, so acidic means there's lots of hydrogen. Basic means there's no hydrogen. The removal of hydrogen ions. So what I want to look at is sometimes what you'll see in the textbook is that when you look at drugs, they'll say it's a weak acid or a weak base, which I didn't write down, but a weak acid or weak base. And let's look at what weak means versus what strong means. If you see the word strong acid or strong base, what that means is that there's complete dissociation. What does that mean? It means that if I take this, this is called sodium chloride, this is table salt. So if I take table salt and I put it in, let me just see if I can draw here, and I put it in a cup of water. Okay, so I take NaCl and I put it in here. What's going to happen is it's going to split. There's going to be sodium and there's going to be chloride. So sodium and chloride. It will dissociate. It will split. And that's what we like. Well, actually, I shouldn't say that's what we like, but that's considered a strong acid where it completely separates. Again, hydrogen chloride. If I put it in a cup of water, it will split. You'll get hydrogen, you'll get chloride, it'll split, and it'll dissolve. Okay, so it'll dissolve nicely in the water. Same thing with a strong base. So with a strong base, this is known as sodium hydroxide. If I put sodium hydroxide in a beaker of water or in a cup of water, it will dissolve and it will split into two. That's why it's strong, because it will split. Weak basically means there's incomplete. I should move this over so we can see better. Oops, that was a bit too far. Okay, a weak acid is when you get incomplete dissociation, where, you know, if I put, so an example of a weak, let me just get my pen here. An example of a weak acid is aspirin. And if I put aspirin in this cup of water, this is like the chemical name for aspirin. If I put this in, it's not going to split equally. It's not going to dissolve equally. There's going to be incomplete dissociation. It won't split. And because it won't split, it's known as a weak acid. Again, if I had a weak base and I put that weak base drug into that beaker of water, it will not do a complete split. And because it doesn't do a complete split, it's called a weak acid or a weak base. So that's the difference between strong acid and strong acid and weak acid, or strong base versus weak base. The difference is that the chemicals, they don't split. There's incomplete dissociation. Another term you might see in your textbook is something called pKa. And pKa, basically, it's a number that is given to a drug. And that number tells you when the drug has equal parts. So when there's 50% ionized and 50% non-ionized, it's like it's balanced. And I'll give you an example. So let's say we have drug A over here. And drug A, for example, if this drug gets entered into the body at the pH of 2, so it gets entered into your body and it's in your stomach area, which is very acidic, what happens, let's just hypothetically say, at the pH of 2, we see a lot of non-ionized drug. So lots of drugs that are not ionized, so there's no charge, and I for ionized, and some drugs that are ionized. So lots of D's that are not ionized, hence no pluses, and some ionized. So it's not equal, right? You can see that. If I take this drug and I put it into let's say the intestines, and it's a pH of 6, what I'm going to see is half of the drug will be non-ionized and half of the drug will become ionized. And so you can see here there's equal amounts. If I put it into an area that is a little bit more basic, what you'll see here in this situation is that there's lots of ionized drugs, not so much non-ionized drugs. Non-ionized refers to this part right here where there's no charge. Ionized refers to charge. And if I put it even more basic, so pH of 9, we're getting even less non-ionized drugs and more ionized drugs. So if I asked you a question, well, what's the pKa of this drug? When pKa refers to when do you have 50% ionized and 50% non-ionized, I'm hoping you guys will say the pKa of drug A is pH of 6. So the pKa of this drug is pH of 6, because when you look at pH of 6, this is where you have 50% non-ionized and 50% ionized, and that is what pKa is, when it's equal, when it's balanced, when we have equal amounts of non-ionized and equal amounts of ionized drugs in our body. And that's important because sometimes we need to know the pH of a drug, and we need to know the pKa of a drug, because that influences our how the drug gets absorbed into our body. You may remember before I talked about, I'm just going to move this here, the pH in our body. So what you can see over here is in our stomach, if a drug gets absorbed into our stomach, the pH is more acidic. It's a pH of 2. But if a drug gets absorbed into our intestines, what happens is the pH is a little bit more basic. It's more of a 7 or neutral. It's more on the opposite spectrum, or on the opposite end. So the pH does change in our body depending on where the drug goes, whether it goes into our stomach or into our intestines. What this slide over here is showing you is that, let's say I give you a drug and that drug is a weak acid. I would tell you, if I give you a drug, I would tell you whether it's a weak acid or a weak base. I'm telling you that I gave you a drug and that drug is known as a weak acid. So what happens to your body when you take that weak acid? Well, if you take that weak acid and this drug gets absorbed into your stomach, let's say, and we know that your stomach has a pH of 2, so it would be somewhere around here. So you take this drug and it gets entered into your stomach, which has a pH of 2, so it's somewhere around here in the scale. Okay, so let's say it goes into the pH of 2, so it enters into your stomach. We know that whenever it's acidic, we always have an influx of hydrogen ions, right? So if you remember this slide over here where I was explaining that when something is acidic, there's lots of hydrogen. When something is basic, there's like the removal of hydrogen ions happen, right? There's no hydrogen. So I gave you a drug, it got absorbed into your stomach, which has a pH of 2, okay? We know that when it's acidic, lots of hydrogen ions is in your body at that point. Now, when there is lots of hydrogen ions, and when you have a weak acid drug, what's going to happen is you're going to have a non-ionized drug. You're going to have lots of non-ionized drugs in that area. Notice that there's no charge. There's lots of non-ionized drugs. And that's good, because when you have non-ionized drugs, it's not bulky, right? There's no plus. It will pass through the cell membrane and it'll get absorbed nicely into your stomach, for example. So it'll start to work. But what if I give you a weak acid drug and this drug gets absorbed into your intestine? And now it gets into a more basic area, into an area that's more basic. Well, what happens when it gets absorbed into your intestines? Well, when it gets more absorbed into the basic section of our body, the hydrogen ion decreases, because again, remember that slide again that I was showing you earlier, when it gets into the basic area, the hydrogen ions goes away. And when the hydrogen ions go away, what happens, okay, in a weak acid situation, what happens is that we get the drugs become ionized, the drugs become charged. And when the drug becomes charged, it's too bulky. It's not going to pass through the cell membrane. It's going to bounce back out. So a weak acid is more lipid soluble. Lipid soluble means it can pass through the lipid membrane in an acidic solution. So if it goes into an acidic area like your stomach, the weak acid will easily get absorbed. But if the weak acid goes into a basic area, then it is not going to go through. It is more water soluble. It'll just stay in the water. It won't go through the cell. So that's what happens in a weak acid. Let's look at weak base. So if I give you a drug and I tell you this drug is a weak base, an example of a drug that is a weak base is local anesthetic. Okay, local anesthetic is always a weak base. So if I give you a weak base drug, and this drug, let's just hypothetically say it enters your stomach, it gets absorbed through your stomach, which we know the stomach is more acidic. And again, I'll remind you again by showing you this over here. If it gets absorbed into the stomach, the pH is low. It's acidic. It's 2. If it gets absorbed into the intestines, the pH is a little higher, a little bit more basic, which is a 7. Now, I know a pH of 7 is considered neutral. It's the middle ground. But let's just hypothetically say that it's more on the basic side, just to simplify things. So what happens? What happens if I give you a drug that is known as a weak base? And how do you know this? I would tell you that this drug is a weak base, or this drug is a weak acid. So I give you a weak base, and it enters into the stomach. It gets absorbed into the stomach, which is more acidic. We know that when it's acidic, we get more hydrogen ions. That rule stays the same, whether it's a weak acid or a weak base. Hydrogen ions always increase in the acidic environment, whether it's a weak acid or a weak base. Now here is the difference. Okay, look at this difference between an acid and a base. When you take a weak base medicine, okay, a drug, and it enters into an acidic area, here what's happening in the base area is you get more ionized drugs. And when you get more ionized drugs, it's bulky, so it's not going to pass through the membrane. This is a huge difference between the acid and the base. It changes, it flips. So when you have a weak base drug and it enters into an acidic area, what's going to happen is the drug is going to become, more of the drugs are going to be charged. And when it's charged, it's too bulky, it's not going to pass through. So a weak base is more water soluble in an acidic solution. This is an acidic solution or an acidic environment. It's going to stay more soluble. It's not going to go through. It's water soluble. But if I were to give you a weak base and it enters into a basic area, into a higher pH area in your body, what's going to happen is you're going to have a non-ionized drug, lots of non-ionized drugs in that area. And when you have non-ionized drugs in that area, it's not bulky, so it's going to pass through the cell membrane. So a weak base is more lipid soluble in an alkaline. Alkaline is another word for basic solution. So if you take a weak base and you put it in a basic area, it's going to go through. It's going to be lipid soluble. So this is just a key thing to keep in mind, that a drug or a substance, it'll become more lipid soluble in an area with a pH similar to its own pH. So what does that mean? That if you have a pH of 2, which is a low acidic drug, and you put it, so if you have a drug that's a pH of 2 and you put it in a pH of 2, you put it in an acidic environment, it's going to go through. If you take a drug that's a weak base, so the drug has a high pH, and you put it in a high pH environment, such as your intestines, it's going to go through. So the higher the pH of the drug, and if you put it in a higher pH area, it's going to go through. The low the pH drug, and you put it in a low pH area, it's going to go through. So one last thing to keep in mind is that, let's lower this so we can see this image. I'll put this image here. Okay. A local anesthetic is considered a weak base. Okay, so all local anesthetics, when you numb an area, or when you get numb, that's a local anesthetic that gets injected into you. That drug is a weak base. So it's more on this side, right? Because acidic is on this side, basic is on this side. Now, when there is an infection in that area, so let's say, this area is inflamed and there's an infection, it's lots of bad things going on here, so it's angry, the gums are inflamed, or this hair area hurts, for example. If there's an infection in this area, anytime there's an infection, this area becomes more acidic. So it kind of goes this way. The area becomes more acidic. And when the area becomes more acidic, what happens is there's always a lower pH. When it's more acidic, it gets a little more angry and the pH gets lower, it gets more acidic. And when it becomes more acidic, remember the rule from last time, when it gets more, it's a weak base, the local anesthetic is a weak base. When it gets more acidic, what happens is the drug, the anesthetic, becomes ionized. The anesthetic becomes ionized. Now, it is a weak base, but because there's infection, it's going to get acidic. And when it's acidic, there's going to be more hydrogen, because anytime you see any infection, there's always more hydrogen. It's more acidic. And because there's more hydrogen, there's going to be more ionized drugs, and so it's going to get bulky, and because it's bulky, it's not going to go through. And so because it's not going to go through the lipid membrane, it's not going to go through the cell, the local anesthetic is actually less effective during infection. It's not going to work in the infection area. So anytime you have an infection, local anesthetic is actually not as effective because the drug is not going to pass through the cell membrane and work. So keep that in mind. When you have an infection, that area becomes more acidic. When it becomes more acidic, the drugs become ionized. When the drug has that charge, it's too bulky, it's not going to go through the cell membrane, and therefore, because it doesn't go through the cell membrane, it's not going to work as well. So the local anesthetic is less effective when there's an infection. I hope that helps.